The science of stargazing dates back to early civilization. I wonder if in this modern age, much has changed. Hi, I'm Leanne Williams, and in today's episode, we're looking at telescopes and more interesting things. Let's check it out.
Telescopes are really very simple things. They collect light. They work in a way a bit like the human eye. You can imagine a telescope as a giant eye. The bigger the telescope, the more light it can collect and the further it can see. And it really is just as simple as that. So if you can build a very big telescope, you can see very faint sources and you can see very distant sources. Sources at the very edge of the universe. Things from which the light has taken over 12 billion years to get to us. SALT is the Southern African Large Telescope. It's the biggest single optical infrared telescope in the Southern Hemisphere. And I think what's so important about the project is that it is an international collaboration. It allows us to work with people from the United States, from Europe, from India, and to bring those resources together to study the exciting things that you can only see from the Southern Hemisphere.
For people like me who love our continent, SALT could be a focal point for development of scientific research in the continent, in the African continent, because we have this fantastic first world, first class facility that can attract astronomers and people who want to do astronomy in the whole African continent, not just in South Africa. SALT is built in Sutherland, and the location was chosen because there was already an observatory existing there. Therefore, there was also infrastructure there. I mean, you didn't have to go and start building an observatory from scratch.
Okay, Herman, back again to 240, please.
Nicola will move to 240.
This is the heart of the telescope, the primary mirror array, which consists of 91 individual mirror segments in a spherical configuration. This is equivalent to a mirror that would be 11 meters by 10 meters in size. Building something 11 meters in size is just, at the moment, technically impossible. So instead, we've made it up from a mosaic of individual segments that collect the light and focus up to the instruments at the top of the telescope. At the moment, we have two science instruments on the telescope. One of them is an imaging camera, very similar to a video camera, which is used to make observations of varying phenomena where the light is varying for one reason or another, possibly on quite short timescales. So this camera can take up to 10 frames a second. And so for things that are rapidly varying, that's an ideal sort of instrument. The other instrument is a spectrograph, which splits up the light into component colours and then analyses what we call the spectra of an object. And so with that instrument, you're able to probe a lot of detail and get a lot of physics out by looking at galaxies and stars and so on. In any given night, we will be observing many different objects for many different programs, which is quite different to the normal classical way of scheduling telescopes where an astronomer might get a telescope to themselves for 1 or 2 nights.
Okay, I should be ready to focus.
All right, track time, hour and a half, going straight through the center of the primary, that's good. All right, Salticam is back on track. Say half an hour from now, extending 45 minutes from that time on, I query the database and it gives me several programs which are visible at that time. In this case, it's only 2 targets. One is looking at galaxies from our Israeli collaborators. Then there's another target looking for Kuiper belt objects. These are small bodies, celestial bodies in the outskirts of the solar system. So we use SALT for science in astronomy, basically from one end to the other. We can look all the way to the very, very distant universe, and we can look at stars in our own galaxy. But then there are programs also which look at objects inside our own solar system. Here's an example of an observation we made recently of asteroids. These were 10-second exposures. See the asteroid moving over here. So every frame is one SaltCam frame from the telescope, and we just put it together and you see the object moving over there.
There's been a lot of science which has hinged around having this camera that could take very, very fast observations. And then with the spectrograph, we were able to do quite a lot of very interesting observations of some colliding galaxies.
One bit of research which we just recently finished was a galaxy called the Bird Galaxy, because it looks like one. It was a surprise that the whole thing was supposed to be only two galaxies, but for the first time really resolved what we call the head of the bird. It really is a galaxy of its own. Everything which is blue over here is new stars being born. On the other hand, the red bits are very obscured regions. There's a lot of dust inside. So with SALT, what we did, we got a spectrum. The bright things are actually emission lines. This is actually hydrogen, and these two are nitrogen lines. A bit further on, you see sulfur, and then there was sodium and oxygen and all those. They are twisted, means that the velocities are different. So this part of the spectrum is actually moving away from us. This part of the spectrum, it's coming towards us. So when you map now this structure on the image what we have, you can build an understanding of how this thing is moving.
The universe is a very dynamic place. Everything is moving with respect to everything else. And it's very useful to have a tool to measure that movement.
As an astronomer, it's fantastic because I have now access to one of the largest telescopes in the world. So the type of science that I can do is just so much increased. There's just so many possibilities.
SALT is a focal point for development of science, research, and technology in South Africa. With SALT, we can motivate young people to want to take up careers in science. And with SALT, we'll be able to come up with exciting discoveries that, they give people a good feel, when you know that there are some good things happening in your country.
What is astronomy? What is astrophysics? Astronomy is basically the study of things above the Earth's atmosphere. Most other sciences got to do with the study of things on the Earth, like for instance biology, physics. Most of the physics we understand today come from experiments that was done on the surface of the Earth. Astronomy is more concerned about things above the Earth's atmosphere. So here's a picture of the Earth. It's about 13,000 kilometers in diameter. And interesting, this picture was taken by the Apollo 17 spacecraft when they left the surface of the Earth. Our nearest neighbor is actually the Moon. It's about 400,000 kilometers away, and it's about a quarter the size of the Earth. Its composition is very similar to the Earth. The other nearest neighbor that we're very familiar with is the Sun. The Sun is about 150 million kilometers away, and it has a surface temperature of about 6,000 degrees. If you go to the center of it, it's a temperature of about 15 million degrees Celsius. And so those are the kind of things that we study. The star is the Sun is a typical star, for those that might not know this, and it will last for another 5 billion years before it runs out of fuel and dies. So now from what we can infer from looking at the Sun, we know today that the Sun is very similar to other stars. So other stars might be rotating as well, and we know this as well from our observation. And then obviously we're part of the solar system, which is this family of planets that goes around the Sun. There's about 8 planets now. When I was at school there was 9 planets, but Pluto has now been reclassified as a dwarf planet. So we leave us with 8 planets. We know that the Earth is the only planet in our solar system that actually harbors life. Astronomers have now discovered more than 400 planets around other stars, and also, so there's hundreds of other solar systems similar to ours out there. The question now is, does any of those planets harbor life? And this is one of the main questions we're trying to answer in astronomy. The other objects that astronomers study that's out part of our solar system is actually things like comets. Comets tells us a lot about the history of our solar system, because they come from the remaining debris of since the formation of our solar system, and so the composition tells us a lot about what the composition was of the solar system when it was born. The other things that we study is also asteroids up here, and some of them is quite dangerous in terms of that they sometimes come quite close to the Earth, and yeah, if anything bigger than about 3 to 10 kilometers hit the Earth, it could be devastating for life on the surface of our planet. And stars come on different colors. This is a picture of the constellation, the Southern Cross, and you can see that some stars actually appear blue and others appear like red yellowish. The difference in color actually tells astronomers that these stars have different temperatures. And now these stars are all different distances from us, and they also come in different sizes. For instance, if you think our sun is big, our sun is about 100 times the size of the Earth in terms of diameter. In terms of volume, it's a million times. So you can fit 1 million Earths into the sun if it was a big sack. So to give you an idea, if this picture actually taken from Wikipedia, if this is our sun, the brightest star in the night sky called Sirius is about twice as big. But if you think Sirius is big, you compare it to some of the biggest stars out there like Aldebaran, which is the red star in the constellation of Taurus. It's about 50 times bigger than Sirius, so about 100 times the size of the sun. And you get even bigger stars. So for instance, if that's Aldebaran, that's Betelgeuse, which is 1,000 times bigger than our sun or so. So stars come in an enormous range of sizes and surface temperatures, ranging from about 6,000 degrees, typical for our sun, down to about 4,000 degrees, all the way up to 10,000 degrees, 30,000 degrees Celsius. So stars come in different physical sizes, but they also come in different masses. And there was a big story broke this year about the most massive star found. And this star was found to be about 300 times the mass of the sun. Previously, astronomers thought it was physically impossible to have stars bigger than about 150 times the mass of the sun, because when stars get too massive, they get too hot on the surface and too luminous, they actually blow the outer layers away. So the big question is, why does the star actually exist? The star's got the funny name R136A1. So if this is the size of our actual sun, that would be the big blue star at the back there would be the size of this 300 solar mass star. Okay, then stars also actually change with time because they have a certain amount of fuel. Stars actually shine because they convert hydrogen into helium via nuclear fusion reactions. But eventually in the center, where the temperature is hot enough, this fuel, hydrogen fuel, will eventually run out and the star will actually die. So our sun is estimated to be about 5 billion years old now, and in about 5 billion years it will actually run out of fuel. When that happens, it will actually swell up. It will actually get big enough that it might just actually engulf the Earth. But long before then, it will get so bright, at about, say, 5,000 times brighter than it currently is, and the temperature on the surface of the Earth will be so high that all the atmosphere and all the water would have evaporated by then. But not to worry, it's another 5 billion years to go. Astronomers measure distances in terms of light travel time. For instance, the distance I said to the sun is about 150 million kilometers. In terms of light travel time, that means 8 minutes. So it takes light 8 minutes to get from the sun to here. So if you think about it, if the sun suddenly disappears now, which, I mean, there would not be reason for it, but if it disappears suddenly, we wouldn't know it until 8 minutes later. And light from the moon, for instance, takes about just over a second. So the nearest star to us is about 4 light years away. So it will take light 4 years from that star to get to us. So if there was some star system with planets around it and there was some alien there who would try to communicate with us, if he sends a message from there, it will take 4 years to get here. And then if we try to respond, it will take another 4 years for our response to get there. So after he initiated this conversation, he'd only get a response about 8 years later.
In studio today, we have two students studying in the field of astronomy, and they are Pierre and Mpati. How are you guys?
Well, thank you.
Hi, thanks. Fine.
Mpati, let's start with you. Do you want to tell us more about yourself and what you do?
I'm a UCT student. I am doing my honours currently, and I study astronomy.
Wonderful. And why the field of science?
Well, it's a very challenging field, and I like being challenged, and thus I decided to go into science because of that reason.
Wonderful. And science has been intriguing you since high school?
Yes, it has. I'm very curious, and I like knowing things. So
wonderful. Pierre, welcome to the show. Tell us more about yourself and what you do.
Well, I'm a student of astronomy at the University of Cape Town. I'm currently doing my master's. And as part of my dissertation, I'm working on the software for a robotic telescope. And most of those activities are done at the South African Astronomical Observatory.
Okay. And why did you find yourself interested in astronomy?
The stars have just always have a very strange and mystical appeal to me. I can't really say why exactly the stars are so awesome to me, but I definitely know, I've known for a long time that I should be in a research field, and so astrophysics was the natural choice.
Wonderful. Mpati, why do you think that the field of astronomy is so exciting?
Like I said before, I think the challenge, and so few people are into astronomy, and it makes it very interesting, and I mean, just discovering new things, is very rewarding. So that's why it's so exciting.
Awesome. Pierre, what was your first impression of SALT?
Well, I just stood in awe at its immense size. It is really spectacularly large, and with it we can see further and deeper into the universe than we have been able to before. Well, okay, of course, there are larger telescopes elsewhere in the world, but it really is a unique opportunity for us in the Southern Hemisphere and for science in general.
Okay. And what kind of research gets done there?
Any kind you can imagine, anything related to astronomy, everything from variable stars and other interesting stellar phenomena in the nearby universe, as in within our own galaxy, to the very furthest and faintest galaxies that are just babies, just forming.
Wonderful. And are there any community projects that are hosted by SALT?
The main one that comes to mind is the SALT Collateral Benefits Project, and part of it was to reduce the unemployment rate in the town of Sutherland. And as a result of the SALT Collateral Benefits Project, they've actually nearly doubled the number of job opportunities in Sutherland.
Okay. Mpati, you were saying earlier that astronomy is not something that a lot of people know much about.
Yes.
What do you find is people's response to you when you tell them about your studies or what you're involved with?
Well, they are pretty amazed, and the very first question I get is there life out there? Which I can't really say at the moment, which is one of the things I'm hoping to find out in my long career in astronomy. And well, if somebody asks me in about 50 years from now, maybe I have an answer to that. Yeah.
Pierre, are there any exciting projects that you're currently involved in?
Well, my main objective at the moment is the writing of the software for the robotic telescope, which I do find very exciting indeed. At times it does get a bit mundane, doing all the programming and everything, but a project that I worked on a few years ago was to actually use data from a similar telescope and do some real science with that data, and there's just nothing more rewarding than that.
Wonderful. Mpati, what are the job opportunities available to students who have completed a degree in astronomy?
With a degree in astronomy, because you learn so many skills, you can really go into whatever you want to go into. You can even go into finance if you feel like it. But most people go into research because of the rewards of science and discoveries and stuff. But we learned a lot of stuff, and you can really, like I said before, do whatever you want to do.
Yeah. And what are some of the most rewarding experiences you've had so far?
Well, for me, it was my honors project, the one I did this year, and discovering stuff that hadn't been seen before. And yeah, that was pretty exciting.
Wonderful. Now to the both of you, can you describe a day in your life, just an average day, what activities you perform, what you enjoy doing? Pierre, we'll start with you.
Well, yeah, so I'll basically go to the observatory and just program for the whole day. That's basically it, sitting in front of a computer. And it's not very romantic, it's not very exciting, but at the end of the day, the result that you get out is just, yeah, incredibly rewarding.
Wonderful. But you do get a tea break in there somewhere,
yes,
right?
Of course.
Okay, awesome. Mpati, what does a day in your life look like?
Well, I'm still doing my honors, so I spend most of my days in lectures where I get to learn new things, which is pretty exciting. And when I'm not doing that, I'm in the office analyzing data and yeah.
Wonderful. And for the learners that are watching this program now, what are the subjects that they have to choose in order to go into this field of study?
You need a very strong background in physics and maths, or science subjects, computer science like projects. Those are the very important ones. And yeah, I think if you have those, then you have a pretty solid background, pretty solid foundation to go into astronomy.
And as you've said, you've loved maths and science from high school, so it's nothing you have to be afraid of. Anybody can do it. Wonderful. And in your opinion, how can SALT benefit South Africa in the future?
Well, the most expensive technologies of today always eventually filter down to every household eventually. I mean, if you take, for instance, microwave ovens, 20 years ago, it was just another piece of technology that was just busy developing. But 60 years ago, radio astronomy was just kicking off, and the development of radio astronomy is undoubtedly related to the development of some related technologies, such as microwave ovens.
Mpati, to end off with, can you give us any advice to viewers who are watching the show right now who are looking to go into the field of astronomy?
Firstly, you need passion. You need to really love science. Be a hard worker. You need to work hard. And yeah, don't be afraid. It is challenging, but it's very doable. Awesome. So anybody can be an astronomer if they really want to.
Wonderful. Thank you so much for joining us today. It's been very enlightening having you here, and we hope to see more of you soon.
Thank you very much.
All right. Wow, I just love things that sparkle. Until next time, take care.